Hi guys, so I'm back for another video, and for today's video I'm going to tackle the summary of chapter 3, the network protocols and communications. Okay, let's start. So in the rules of communication, it includes the rules. So the rules has a communication fundamentals, rule establishment, message encoding, message formatting and encapsulation, message size, message timing, message delivery options. So in communication fundamentals, it is a network can be as complex as devices connected across the internet, or as simple as two computers directly connected to one another with a single cable and anything in between. Then the rule establishment is before communicating with one another, individuals must use established rules or agreements to govern the conversation. Then message encoding is one of the first steps to sending a message's encoding. Encoding is the process of converting information into another acceptable form for transmission. Then, message formatting and encapsulation. When a message is sent from source to destination, it must use a specific format or structure. Message formats depend on the type of message and the channel that is used to deliver the message. Next is message size. Message size is another rule of communication. So when people communicate with each other, the messages that they send are usually broken into smaller parts or sentences. Then message timing. These are the rules of engagement for message timing. It includes success methods like also flow control. Then the message delivery options is a message that can be delivered in different ways. Okay, so next is the network protocols and standards. So it includes protocols and protocol suites, standard organizations, and reference models. So first, in protocols, it includes rules that govern communications, network protocols, and protocol interaction. So the rules that govern communication are a group of interrelated protocols necessary to perform a communication function is called a protocol suite. Protocol suites are implemented by host and networking devices in software, hardware, or both. Then, network protocols. At the human level, some communication rules are formal and others are simply understood based on custom and practice. Then in protocol interaction, communication between a web server and web client is an example of an interaction between several protocols. The protocols are like the HTTP, TCP, IP, like that. Okay, next, protocol suites. So in protocol suites, it includes protocol suites and industry standards, development of TCP/IP, TCP/IP protocol suite, and TCP/IP communication process. So first, protocol suite and industry standards are a set of protocols that work together to provide a comprehensive network communication services. A protocol suite may be specified by a standards organization or developed by a vendor. Protocol suites and industry standards. Next is development of TCP/IP. So the first packet switching network and predecessor to today's internet was the Advanced Research Project Agency Network, or ARPANET, which came to life in 1969 by connecting mainframe computers at 4 locations. Next is TCP or IP protocol suite. It includes many protocols. Some of the more popular ones are shown. So the TCP or IP protocol are some of the protocols. So next, TCP or IP communication process. This process and these protocols will be covered. So it just include in this another lesson. So next, standard organizations. Open standards. Open standards encourage interoperability, competition, and innovation. They also guarantee that no single company's product can monopolize the market or have an unfair advantage over its competition. Next is Internet standards. Standards organizations are usually vendor-neutral, non-profit institutions established to develop and promote the concept of open standards. Next, electronics and communication standard organizations. Other standard organizations have responsibilities for promoting and creating the electronic and communication standards used to deliver the IP packets as electronic signals over a wired or wireless medium. Next, reference models. First, the benefits of using layered model. The benefits to using a layered model to describe network protocols and operators include assisting in protocol design, fostering competition, preventing technology or capability changes, and then providing a communication language to describe networking functions and capabilities. Next is the OSI reference model. The OSI model provides an extensive list of functions and services that can occur at each layer. Next is the TCP or IP protocol model. The TCP or IP protocol model for the inter-network communications was created in the early 1970s and is sometimes referred to as the Internet model. Last is OSI model and TCP or IP model comparison. Next, data transfer data transfer in the network. So it includes data encapsulation and data access. Data encapsulation includes message segmentation, protocol data units, encapsulation, and de-encapsulation. So first, excuse me. What is message segmentation? In theory, a single communication such as music video or an email message could be sent across a network from a source to a destination as one massive uninterrupted stream of bits. If messages were actually transmitted in this manner, it would mean that no other device would be able to send or receive messages on the same network while this data transfer was in progress. These large streams of data would result in significant delays. Further, if a link in the interconnected network infrastructure failed during the transmission, the complete message would be lost and have to be retransmitted in full. Then protocol data units. As application data is passed down the protocol stack on its way to be transmitted across the network media, various protocol information is added at each level. This is known as the encapsulation process. So the encapsulation is when sending message on a network. The encapsulation process works from top to bottom. At each layer, the upper layer information is considered data within the encapsulated protocol. Last is the encapsulation. This process is reversed at the receiving host and is known as the encapsulation. The encapsulation is the process used by a receiving device to remove one or more of the protocol headers. The data is the So last is the encapsulation. This process is reversed at the receiving host and is known as the encapsulation. The encapsulation is the process used by a receiving device to remove one or more of the protocol headers. The data is encapsulated as it moves up the stack toward the end user application. Next is data access. So it includes network addresses, data link addresses, and devices on the same network and devices on a remote network. So first, network addresses is the network and data link layers and responsible for delivering the data from the source device to the destination device. Next is data link address. The data link is a physical address as a different role. The purpose of the data link The purpose of the data link address is to deliver the data link frame from one network interface to another network interface on the same network. Devices on the same network. To understand how devices communicate within a network, it is important to understand the roles of both the network layer addresses and the data link addresses. Next is devices on a remote network. The roles of the network layer addresses and the data link layer address when a device is communicating with a device on a remote. The role of the network layer address is when the sender of the packet is on a different network from the receiver. The source and destination IP addresses will represent hosts on different networks. This will be indicated by the network portion of the IP addresses of the destination host. Okay, so this is the this is the summary of chapter 3. Thank you for watching and bye.